Leaks are a problem experienced by almost every vacuum user. Leaks can occur suddenly or develop slowly over time, but in either case, they can cause damage. Someone at Kurt J. Lesker Company, who for many years earned his living elsewhere detecting leaks, once remarked, "There are thousands of large leaks, hundreds of smaller leaks, and tens of very small leaks. The occasional leak in the 10 to the minus 8 torr range, and only one I've ever seen at 10 to the minus 9 torr. Most of these leaks, except for very small ones, are easy to detect. The general principles of vacuum leak detection are simple. You spray the side of the tank that is outside the vacuum chamber with a gas or liquid that gives a response to the detection device. The gas, or vapor, diffuses through the leak, displacing the air, and the output of the detection device changes. There are many different types of leak detection systems, and most common include a leak detector, which is a self-contained mass spectrometer tuned to the mass of helium. In this video, we will discuss the solvent method for detecting leaks in your vacuum systems, which is a great starting point before you track down a helium leak detector. Because pressure reading at vacuum gauges is sensitive to the type of gas involved, it is possible to brush or spray suspected leaks with alcohol. The alcohol vapor which flows into the device changes the pressure reading of the vacuum gauge, since the thermal conductivity and ionizability of alcohol vapor vary from the properties of air. The procedure for using alcohol is the following. First, start the pump down procedure using the rough and turbo pump, and let the chamber come to as high of a vacuum as it can with the leak. Then, while monitoring the vacuum on your turbo pump or rough pump with a TC gauge, squirt some isopropanol or methanol on suspected flanges while watching the vacuum gauge. Typically, the vacuum will come down or the pressure will go up when the alcohol finds its way into the leak. With this method, one must be careful to allow enough time for a pressure increase to take place. The solvent method is effective for locating vacuum pump leaks that are large in size. For mid-vacuum leaks, the ion gauge will function and the vacuum will be between the low 10 to the minus 3 torr and the high 10 to the minus 8 torr range. For high vacuum leaks in the low 10 to the minus 8 torr to the low 10 to the minus 9 torr range, squirting the flange with isopropanol or methanol usually will not work, and you'll probably need a helium leak detector. Gross leaks are the type where the chamber will only pump down somewhere between the atmosphere and the low 10 to the minus 2 torr range. With this type of leak, the vacuum is not good enough for an ion gauge to turn on, and the change in pressure can be watched for on the TC gauge. If you have a large enough leak, you might even hear a sucking noise, and you can probably find that sort of leak by putting your ear next to each part of the system. Remember that leaks are most likely to be near wherever some work has been recently done on the system. There are multiple solvents with high vapor pressure that can be used for leak detection: acetone, methanol, and ethanol. Acetone has the disadvantage of being harmful to O-rings, filaments, and to your health. Be aware, when you find a leak, the pressure will often rise because the molecules can go through the leak, but it could also drop because the freezing of the evaporating liquid temporarily seals the leak. Be sure to observe all required safety precautions when using hazardous solvents, including proper ventilation and spill containment. Don't let flammable solvents accumulate on the floor of your lab. Remember also that in many cases, these solvents will remove paint, so be careful with your instrument.